Okay, now we're on to 4.2 exponential functions, day 2. This is where we get to see how it works in the real world. And we're going to be talking about rates of inflation. Whenever we're talking about rates, it's often given to us as a percent, but whenever we do the calculations, we need to change that into a decimal. And remember, you move the decimal left twice, so this is a 0.04 is my rate. It says I bought an Altima in 2010 for $25,000, and we're going to write an exponential function. And going back to Algebra 1, I want to remind you that our general formula is y equals a b to the x. A is always your initial amount. That's what you start with. It's also your y-intercept. X, your exponent is always time. And b is always going to be either 1 plus your rate, if it's growth, or 1 minus your rate, if it's decay. Okay, so that's my general form, y equals a b to the x. So my a is my initial amount. We bought this Altima in 2010 for $25,000. That's what it started out as. So I'm going to say that my y is 25,000. And then in the parentheses for b, I'm either going to add my rate to 1 or subtract it from 1. And if we're talking about inflation, inflation means that it's going up. So I'm going to add my rate to 1. So inside my parentheses, I have 1 plus 0.04, and then x is my time. So I'm going to go ahead and combine the 1 plus 0.04. So my model is 25,000 times 1.04 to the x. To get the model, what you're doing is you're plugging in everything except the x. Plug in everything except the x. The x is going to be part of your model. And then we can use this for any situation down the road. So the next part says, find what I would expect to pay now for a similar car due to inflation. Well, if this was in 2010, it's currently 2021. And actually, let's just use, just for the sake of ease, let's pretend that now is actually 2020. I know we don't want to pretend now is 2020 because 2020 was not our best time, but it's going to be easier to calculate. And I already have that worked out. So my x is 10, okay, because it's 10 years from 2010 to 2020. When you put it, I didn't leave myself enough room to do this, did I? So when I plug that in, right, all I'm going to do is take my model and plug in 10 for x. So this is y equals 25,000 times 1.04 to the 10th. And you'll run that on the calculator and you should get 37,006.11. Make sure you put commas in when you're putting stuff into Schoology. Okay. Next example. When you buy a new car, it depreciates in value by 8% each year. Okay, so depreciates tells you that it's decay because it's going down in value. My rate is 0.08. Remember, you have to take your percentage and turn it to a decimal. And we're still talking about that car that we bought for $25,000. Okay, so two different things. One is the value of the car. If we're talking about inflation, inflation makes things go up. Usually the cars don't appreciate, right? Usually inflation affects, like, or houses are appreciating, but cars depreciate and go down in value every year. So if we write the exponential model, we have y equals our original amount, which is 25,000. Then in parentheses, it's going to be 1 minus my rate because it's decay, and my rate is 0.08 to the x. And you go ahead and finish what's in the parentheses, so I have 25,000 times 0.92, 0.92 to the x. That's my model. And then I'm going to use that model to find out the value of the car. And remember, we're using 2020. which means my x is 10. So I'm going to take my model, y equals 25,000 times 0.92 to the 10th. And when you work that out, my car has gone down to 10,000. It's worth less than half. 859.71. Okay, and those are my examples for today, day 2. Thanks.